Hi, and welcome to this informative session where we'll cover the ASCE 7 wind enclosure classification calculation here in the Structural Engineering Library. You can find this calculation here in the Loads and Forces division, and it's this item that I've just highlighted called ASCE 7 wind enclosure. I'll just pop this open so that we can take a look at the important parts of this module. The purpose of this module is to assist the engineer with determining whether a building qualifies as an open structure, and if it does not, then it goes on to help the engineer determine for each of the four walls in the structure receiving positive external wind pressure whether the building qualifies as either enclosed or partially enclosed. So here's a sample of how we might use this enclosure classification calculation. We'll just put in something like building 1 for our description. I'd also point out that we've implemented a series of tabs here on the side that allow you to use this calculation for multiple evaluations within a given project file, and the other thing, the all-important print checkbox if you do want the information for the selected tab to be printed when you do a project print. Next, what we'll do is we'll just work our way through and give the module the information that it asks for to determine whether the building happens to qualify as an open structure. And the first thing that I'll do is just simulate a structure that does qualify as being open, perhaps a pole barn or a large gazebo, where the majority of the wall elevation is actually opening. So I've just entered a situation where I've got 100 square feet in each of the four elevations, and 90 square feet of that 100 in each direction is an area of opening. And so here we can see the way the module reports that it satisfies the requirement that the area of openings be greater than or equal to 80% of the gross area for each of the four walls, and this building would qualify as an open structure. Now that's fairly straightforward, but let's just change things up a little bit, and let's assume that we have something that's a little bit different here. Let's reduce things down to a fairly small area of openings for the majority of the walls, but let's just keep one of them relatively wide open, and we'll come back to the 100 square feet for that west wall. Now what happens is it correctly indicates that we don't meet the requirements for an open structure for any of the four directions, and that's what this message is telling us here. Once it determines that the structure is not open, then a new pair of input fields open up, those being for the roof, to collect the area of the roof and any potential area of openings up in the roof. We can see our totals, running totals tabulated for us. And then what we're doing at this point, once we rule out the possibility of it being an open structure, is that we're actually looking at all four wall elevations in turn, being the one that receives positive external pressure. And now what we're doing is checking to determine whether the structure qualifies as being either enclosed or partially enclosed for each of those respective elevations, being the windward wall. So on these tabs down here, we can see results when the north wall is the one that receives positive external pressure. And in fact, because I've created such a large area of openings in that north wall, the building qualifies as being partially enclosed when the wind hits the north wall. It creates positive external pressure on the north wall. We can see that the values are tabulated here for us, just following through the steps in ASCE 7 to determine whether the building is enclosed or partially enclosed. And in this case, since it satisfies all three of the criteria, it is partially enclosed for that direction. Now if I move to the south wall, we can see that in this case, because the area of openings in the south wall is relatively small, we actually fail one of the three criteria here, and so it can't be partially enclosed. The building is found to be enclosed when the south wall receives positive external pressure. And if I quickly click through the east wall tab, we see the same story there, and the west wall tab, the same story there as well. So what we have found is a situation where we have a building now that qualifies for being partially enclosed when the north wall is the windward wall, but it qualifies as being enclosed when all three of the other walls receive positive external pressure. So it's a fairly simple calculation, but hopefully the module will make light work of it and make it just a little bit easier to determine that enclosure classification and perhaps a little bit neater to document it for the project. So we hope that this has been helpful. And as always, if there are any questions, comments, or suggestions, please feel free to let us know. You can contact us at support@enercalc.com. Thanks very much. Take care and have a great day.